Hello to all Godot developers in Hefei. My name is Tamás, and this is a crash course in multiplayer. So, I like multiplayer games. They are fun, you can bring your friends, you can have some competitive fun, you can maybe do something laid back, play something cooperative. It's usually a good time. But the issue is that these games can be quite difficult to make. And I think part of the reason is that, they can be a bit difficult to conceptualized. They can be quite mysterious. You're not sure how to approach them best or even properly. So today I will be talking about some of the challenges with building multiplayer games, some approaches you can take to actually finish a game and maybe keep your sanity on the way. And I even have a mystery item at the end. So let's see the challenges. I have found 3 challenges specifically, which are synchronization, latency, packet loss, and my +1 is cheating. So I start with synchronization. So this is really not something that you are probably thinking when you are building your single player game. But if you think about it, multiplayer games are games where each player is seeing approximately the same game world. And the way you do this is basically you synchronize all your data that you need to display this game world. And something that you might want to consider is what to actually transmit and synchronize. Now there's data that is really important for gameplay, like how much health do you have, how many bullets you have left, or even what's your position, where you're looking, where you're aiming, etc. But there's also data that is nice, but you don't really need to synchronize it. Let's say, which way is that blade of grass looking as it's swaying in the wind? That's a really nice feature, looks really great, gives a lot to the visuals, but you also don't need to synchronize it. If that blade of grass is, oriented in different directions on each player's PC, that's fine. Now, the other thing to consider is who will transmit which piece of data. And by this, I'm thinking about Godot's concept of multiplayer authority or ownership. And this basically means that if I have authority over a node, so I own the node, that means that I get to tell the node's state and run RPCs on it, and other peers should trust me. So let's say I have authority over an item node. So when I say that this item is actually consumed, there's no charges remaining in it, then every other peer should trust me because I'm the authority on this node. And lastly, the question of where to transmit, and by this I mean which players should receive which piece of data, because not every player should receive everything all the time. So let's say you have an ability that turns you invisible. You're just gone, poof. And the other players, they won't render your avatar on their screen, but if you still keep sending position updates, even though you are invisible, they can just use that data. Any cheater can just display those location updates, and they will know where you are, even though you are supposed to be invisible. Next up, latency. Even if you send the data, unfortunately, it takes time to arrive, and you can blame the speed of light and the laws of physics for this. Unfortunately, there's not much going around this latency issue, unless you are making a game that should be played on local area network only. In that case, latency is probably not an issue, but I have a feeling that most of you don't want to build games that only work on the same network. So latency actually can be fine. You can just accept it as it is. Say for turn-based games or UI actions, you press a button, it takes some time, something happens, you are happy. That's fine. You expect it to take a bit of time. You don't really mind it, as long as it doesn't take too long. But you can also try to mask your latency like come up with some game design trick or approach that kind of hides this latency. And one really cool example, I think, is how World of Warcraft does spells. In case you have never played the game, if you press a button that you want to cast a spell, it won't happen instantly. Instead, you get like a progress bar saying that you are casting the spell, and it just takes some time. And this is a game design decision, so players are fine with it. And really, not many people are thinking in the back of their minds like, hey, actually, this is because it takes time for that request to arrive to the server and for the server to reply that, yeah, good job, you have cast this spell. That's not what people are thinking. So in this case, we have successfully hidden this latency by using a game design decision. But there's also cases where you need to compensate latency because latency as is not really acceptable. Let's say if I'm playing a first-person shooter, I press a button to move, I move my mouse around to look in some direction. I want that to respond instantly. I don't want to wait for the data to go to the server and then the server to reply like, hey, yeah, you have successfully moved to the right, so my view shifts to the right. There's just too much time. It feels bad to play. So that's not something that you want. You need to compensate somehow. And I talk a bit about how to do that, but I have to note in advance that it can get complex. Next up is packet loss. So even if you send the data, sometimes it just doesn't arrive, it doesn't make it there. And this can be fine. Let's say about when one of your position updates gets lost on the wire. Like many games are sending these position updates 30 times per second or even 60 or even 120 times per second. So if you miss out one or two updates, that's fine. The next update will arrive in milliseconds, so nobody will notice much and the game will just go on. But sometimes people will notice and the game won't go on that well. Let's say if an important key press gets lost on the wire, say you have your perfect shot lined up, you press fire and nothing happens because the packet that says to the server like, hey, I want to fire my gun, gets lost on the way, never makes it to the server, you haven't done anything, game ruined. So I have to note on this that many networking solutions, including Godot itself, offers unreliable and reliable channels to transmit data. And unreliable means just that. It basically means that you send the data, it may make it or it may not. It might get lost. But for reliable, under the hood, it usually uses the same unreliable transport mechanism. But the difference is it can notice that the packet didn't make it and it will send it again. Like it will ask like, hey, did you receive this packet? No, I did not. Okay, I'm sending it again. Did you receive it? Yes, I did. And now the packet is there. So it will get there eventually. It just takes time. This kind of back and forth can introduce some latency. Right, and lastly, cheating. So in order for people to be able to play your game, you have to send them your game, including the executable file, which means that the client has the executable, which means that they can tamper with it, they can modify it, they can implement cheats. So unfortunately, this means that you can't really trust the client. And this can actually be fine. Like cooperative games where there's not much to win by cheating, that's fine. You probably don't need to worry about as much. But on the other end of the spectrum, competitive games, cheating can absolutely ruin a match or a game. So in those cases, you might do good to think about it. But in general, the less trust you put in the client, the less room you leave for cheats. All right, now let's talk about some approaches. I wanted to mention 3 specifically: making your game client authoritative, implementing a deterministic lockstep, or even rollback. So starting with client authoritative, I think it's kind of the simplest. It's basically you go, I own my own stuff. So each client owns their own avatar. So that means if you press a button that you want to go to the right, it happens instantly because you are the authority on your own avatar. You broadcast that, and then everybody is synchronized. And this is great. Responds instantly. You don't have to wait for anything at all. And this is really the only approach from these three that I want to talk about that is pretty easily supported by Godot. You can just use the built-in multiplayer synchronizer node for this and it will be fine. But since you are the owner of your own avatar, you can start saying stuff like, yeah, no, actually your shot didn't hit me at all. Actually, I'm always on full health. You know what? Actually, I can fly, so I just fly out of here. And, this sounds pretty funky, but since you are the authority, every peer will just believe you. So it is really easy to cheat with this approach. And also, in some interactions can get a bit difficult to do. Let's say you have a team, they are using a shared resource. Both of them are saying they spend the last remaining amounts of this resource. How do you figure out who did it first or who should you trust? There's no central authority on this, so it's a pick-up. So this is something to consider. But what if I have a game with like an army, a bunch of tiny dudes that I can control and they are just running around on the screen? What if I have a real-time strategy game? Surely it sounds too much to synchronize each individual unit. So instead what we do is send our inputs to everyone, wait for everyone else's inputs to arrive at us, and once we get all the inputs, we simulate a tick and we advance the game loop. And the really cool thing with this is that you only send inputs, and inputs are stuff like, I want to select all my guys in this box and then send them to this other point in the map to attack. And there's barely any data. You can do that with really few bytes. But the issue is that since you have to wait for everyone's inputs, if you have all of your players with just excellent connection, almost no latency, but you have one person with a horrible connection, data takes forever to arrive, you have to wait for that input as well. So in this sense, the worst latency is the latency for everyone. And the other issue is that your simulation must be deterministic. Since our big win here is that we don't synchronize the game state, we must create a game simulation that produces the exact same output for the exact same inputs. So this means that you have to consider things like CPU architecture, operating system, possibly even specific CPU models. If you involve the GPU for some massively parallel compute, maybe you need to make sure that that part of the simulation is deterministic as well. You have to consider NDNS, floating points, etc. So in this sense, you really need to produce the exact same bits of game state, which can be complex. This can be done, this has been done, StarCraft 2, Age of Empires, many RTS games already do this. Just take note that this can be difficult. Alright, so let's consider rollback, which is kind of like reconciling parallel universes and time travel in real time, which sounds like a mouthful, but let me clear it up. So what we do is each client submits their input to the server, pretty similar to some earlier approaches, stuff like I want to move to the right, but instead of waiting for the server to reply, we just move our screen to the right, as in each client predicts the outcome of their inputs. And now the server receives all the inputs, processes them, sends out the updates, and if we predict it correctly, then great, the server agrees, we have predicted successfully, we didn't have to wait for anything. And if we mispredicted, then we can correct our game state based on what the server sent. And it's important to note that when the server receives inputs, it knows that those inputs take some time to arrive to the server. So actually the server rewinds the game state back to the point where the input was sent and simulates the game from there. So this has some benefits. As mentioned, it is responsive. Clients don't have to wait for anything. And since we have this kind of resimulation solution, we can model interactions a bit better. For example, both players spend the same resources. We are now actually rewinding in time and finding out who did it first. So in this way, we have a central authority. But the con is that this is complex to implement. Okay, and now for our mystery item, it's NetFox. So what is NetFox? It is basically a set of add-ons for building multiplayer games. And if it covers what you need pretty well, then you can just use it as a framework and everyone's happy. But if it doesn't specifically cover what you need, you can use it as a library. You can use it as a set of tools that you can build upon. You can even build your bespoke networking solutions on top of NetFox specifically for your game. So what's in NetFox? Well, it implements rollback. So if you want to build rollback-based games, then excellent, you have NetFox now. But if it doesn't, it still gives you a tick loop, similar to Godot's physics process, just specifically for netcode. You get a clock synchronization implementation similar to NTPv4, the same thing that synchronizes your PC's clock. Similar, not the same, but the same precision. You also get configurable data sync. So you just tell NetFox what properties you need synchronized, and then NetFox does the rest. You get diff states, which basically means that NetFox only sends data that has changed since the last update instead of sending everything. So that can save you a bunch of bandwidth. You get schemas, which are basically NetFox's version of custom serializers. So you can tell NetFox how to serialize some property before sending it over the network, saving you some bandwidth again. You also get visibility filtering, which is a great fit for your invisibility ability example. So you can decide who gets what piece of data. And even though Godot does not really support this, we can also do rollback physics with NetFox. So you can even do some physics-based multiplayer games and have them be responsive. Right, so a quick demo time on how to actually use NetFox. I have taken a really simple game, just these little tic-tac guys that can walk around. You have your usual nodes, your player, your collision shape, your mesh instance. Then you also have some nodes specific to NetFox. First off, for the rollback implementation to work, you need a specific node that has all the input properties. These properties basically tell stuff like, I want to go this direction, I want to shoot, I want to jump, etc. Then you also have a rollback synchronizer, which basically lets your node participate in NetFox's rollback implementation and synchronizes all your data. In this case, on the right, we have state properties. These are properties that we need synchronized. And in this case, it's the position of our player. And we also have input properties that tell NetFox what your player wants to do. And in this case, it's the movement property on our input node. And then you also have tick interpolator, which is used to basically interpolate your visuals between ticks. So let's take a look at our input script. And here we have our movement property. And all you need to do is implement a gather method that only runs if the player actually owns this input node. And if it does, this is where you can query your input, for example, by using the input class, and then set your input properties. And these input properties are important because they are used from the player script. So let's take a look at that. So in some aspects, this might be familiar. This is mostly the built-in character body 3D template where you can walk around and jump. And what you need to notice is that we have a reference to our input node that we will be using. And instead of implementing our game logic in physics process, we implement it in rollback tick. Otherwise, the logic is mostly the same. The important distinction is that we don't check for input directly, but we use the properties on the input node. And if we run this tiny game, okay, let's host on this guy, move him to this corner, connect, move them to the other, and let's move around. And you might have noticed that the game was a bit janky on the start. Well, that is because we are running on 200 milliseconds of ping, so that's the time it takes for data to get to the server and arrive back to the client. But as you can also see, if I'm pressing any buttons, it responds instantly on my screen as the client, and the data is still owned by the server. So this is rollback in action. Okay, and continuing with the presentation itself. Okay, so just a few more points about NetFox. The repository also contains some examples, so you can check out some of the features and how to use them. It also has Forest Brawl, which is a small game fully implemented with NetFox, so that you can use it as a reference. There's also a documentation site, and there's also two related projects that I would like to mention. Firstly, there's an array. It basically saves your players the trouble of port forwarding and such. It can do NAT punch through or act as a relay if needed. Basically lets your players connect to each other. There's also NoHub, which manages lists of lobbies for you, so your players can browse or just jump into a session randomly. And both of these projects, similar to NetFox, they are open source, and these two are self-hosted, so you can deploy it whenever or wherever you'd like. But there's also public instances available, so you can experiment with them before committing. And just some closing thoughts. Is netcode solved now? Can you just build anything easily without thinking? Unfortunately, no. Multiplayer can still be difficult, but hopefully much less so with NetFox. So can you build an RTS game with NetFox? Yes, no, kind of. Basically, NetFox implements rollback, and that is not that suitable for RTS games, as we have discussed earlier. But you can build an RTS with NetFox in the sense that you can use it as a toolset, a library, and you can implement your own lockstep solution on top of it. So do you need to build custom parts for your game? Maybe. If your game is a bit simpler, or if just everything is covered that you need by NetFox, then great, we have one. You can build your game without much extra code or effort. But there's also cases where NetFox doesn't cover everything you need. In that case, yeah, you probably need some custom parts. And that is all I wanted to cover today. I have left some links on this slide. Unfortunately, I can't take questions now, but if you have any, or if you would like to talk just about NetFox, networking, game development, anything, I invite you to our Discord server. The link is up on the screen. And I think it's a good community both for getting to know NetFox, but also to just discuss netcode in general. So I hope to see you on our Discord, and I hope that this presentation was useful and you are maybe that much closer to building the multiplayer game of your dreams.